Welcome back, everybody. We're still talking about futures, one of my favorite types. And what we're going to do now is we're actually going to get rid of the futures in our types. Because it's kind of nice to see try of t and future of t in the type, because that makes the types more honest and more precise, because looking at the type signature, we can now see, oh, this function might fail, or this function takes a long time. But the price that we have to pay is that we have to write things using flat map and higher order functions, where sometimes really what we want to do is we want to write just simple, old-fashioned control flow. And async await is a feature that allows you to kind of, go back, forget about futures and so on in a limited context, and then just write regular imperative code. So what we want to do is we want to make effects implicit again, but in a limited scope. All right? So we still, like on the outside, it still looks like a function that returns a future or a function that uses try. But internally, we want to treat it inside our code, we want to just treat it as a regular function from t to s. Okay? Now, there's a feature here in Scala. It's called Async Await. And what that allows you to do is when you have code inside an async block, then you can use await around something of type future and get back a t. So that's a miracle function here, right? So this is a function here, this await, that allows you to get rid of the future in a magic way. Also notice that this async here takes an execution context. We're going to ignore that. But the magic that we want to use here is that this allows us to just forget about the future and just get a regular value back of type t. Now, async await has become very popular to do asynchronous programming. If you look at C#, it has support for async await. JavaScript will have support for async await. Facebook's Hack has support for async await. And also the Dart language from Google has support for async await. So even if you're not using Scala, this is super useful knowledge, because it is a language feature that will be in any modern language. Now, this thing comes with a lot of small print, the Scala version, and it might be frustrating when you use this. There's a lot of small print. You cannot use it anywhere in all situations. You cannot use it with try-catch. You cannot use it with nested functions. So it's a little bit primitive, but it's still worthwhile the trouble, in my opinion. Okay? You will be screaming and crying because of the horrible compiler error messages. This thing is implemented, using macros, and it will spill all the guts on your screen. Just bite through it and you will love it, all right? Because in the end, it's worth it. Your code will be much simpler and much readable. But you have to be patient and you have to kind of go through some pain. But no pain, no gain, all right? So let's look at our retry example and kind of write that using regular imperative control flow and async await. So what you see here, up here, is that I have an async block, which means that inside the async block, I can use the await. When there's a future, I can get that into a regular result. Okay? So what I do now is I just declare a variable. I have my result type, and then I just go into a loop. And as long as the result is failure, and I've not reached the number of times, I'm going to kind of, try the result. If the result succeeds, then this condition fails. I fall through, and I return the result. Okay, and there we're using this function here that takes a future and returns it into a future of try of t. to make the try explicit. So I think this code looks pretty nice, and the reason is that I can just use a while loop. Now let's look how we define filter using async await. Again, look here, we have the async block, and what we can do now is we can await ourselves. So this was of type future of t. So when I await that, I get a value of type t, and then I just check if p holds, then I return x, and otherwise I throw an exception. Now this looks really, really simple because this is the way you think about filter. Filter is something like a conditional. A flat map, it's even nicer. So a flat map takes a function that, given a t, returns a future. This is the instance method, so the this is future of t. So how can I call that function? Well, to do that, I first have to take a future of t and turn it into a t. Ha! But magically, if I'm in this async block, I can use await, so I just await myself. Now I get a value of type t. I call the function, which returns a future of t, but since the await wraps another future on it, I have to await that f of x, and everything goes well. Now look how beautiful and elegant this code is. Now in the next lecture, we will introduce promises, which is another mechanism to create futures, and their filter will look like this. All right, and don't understand the code yet. That will be in the next lecture. But you will see that you see immediately that that code is much longer than this code that uses async await, and so I prefer the async await version. So thank you very much. Next lecture we'll talk about these future things that we silently introduced here.